I think that is one of the big differences to RisingWave, where you really just feed in data and you get this like live updating of the actual data table, basically.
I think the simplest way to explain a streaming database is that we can just consider it like a standard database system, but tailored for stream processing. It's static. It's not that dynamic. If you change the base table, if you insert new tuples into the base table, the materialize view won't change. And that's Postgres materialize view. Don't just focus on AI. Think about the data infra. Because, well, I mean, I talked to a lot of people, and people say that, okay, why you are still working on data infra, right? Data infra is that, right? Look at the Snowflake stock, and it's dropping every single day.
Hello, everyone. Welcome back to this week's episode of Simplyblock's Cloud Commute podcast. This week, again, an incredible guest. Like you know the spiel. I say this every time, and it's true. So I have to repeat it. All right. So with me today, I actually have. Oh, I didn't ask for how to pronounce your name specifically, but I think it's Yingjun Wu.
It's pretty good. Yeah, pretty good.
Probably close enough, or as close as I can get. From RisingWave, Jingwu, Jingyun. Sorry.
Okay, let me do an intro. Okay.
Yeah. Just go ahead and introduce yourself.
Yeah. People always will. I mean, a lot of people ask me. Okay, every time I do an interview, I mean, they will ask me about how to pronounce your name. Okay. Anyways, well, I mean, if you're not familiar with how to pronounce Asian names, well, my name is Yingjun Wu, and Yingjun, yeah. And I'm the founder of RisingWave Labs. So RisingWave is a stream processing company. And so a lot of people ask me about, okay, why you're working on stream processing, right? And it's like, okay, probably it's not like, okay, Postgres, right? But it's not like things like for Redshift or Snowflake, this kind of thing, right? So basically, a little bit intro about my background. Well, I did my PhD in stream processing and database systems, almost 10 years ago. And at that time, there was no stream processing systems. Well, I mean, there was no systems called Spark Streaming, Flink, Samza. There's no such kind of systems. It was just like single node database system called, well, they're probably in Microsoft. There was Microsoft Streaming Insights, and there are some research projects. Okay, and after I graduated, obtained my PhD, I joined IBM Research Center, Armadan Research Center in South San Jose, and doing research in stream processing and transaction processing, basically transaction databases. And what I was working on was a project called IBM DB2 Event Store. So basically Event Store. So it's such a name. Basically the storage for storing a database for storing event data, right? And then afterwards, I joined AWS Redshift. And AWS Redshift was like, okay, the warehouse, right, for storing data. And I was working on saying very cool things such as vectorized scans, vectorized executions, decoupled compute and storage architecture, and materialized views, and some other cool technologies. And I found that, okay, Redshift is great technology, but it's for batch data, right? But what I can see is that, obviously, more and more people are using streaming data. They have the streaming data, and they really want to have the stream processing capability, so that they can gain the insights directly from the streaming data. And that's why I started a company called RisingWave, because it's wave, right? So it's water and it's stream, right? And so I started a company and working on the open source technology, because I really believe in the open source.
Oh, that is, now the name makes sense. I always wondered how you came up with RisingWave. Oh, that makes sense. Sure. Yeah. Okay. The second it clicks, like, okay, yeah. So maybe give us a quick introduction into RisingWave. You already said it's a stream engine or a stream processing engine. What are like the typical use cases that you see?
Yeah, I mean, RisingWave officially is a streaming database, but it's always people always wonder, okay, what is a streaming database, right? People probably heard of operational database, ORTP database, or analytical databases, right? OLAP databases. But what is a streaming database? I think a simpler way to explain a streaming database is that we can just consider it like a standard database system, but tailored for stream processing. The other way to think about it is that we can process streaming data in a Postgres way or in a database way. Like you can just, create a table, create a materials views, doing queries there, right? Well, that's a streaming database. So if you talk about the use cases, in most cases, it's about the real-time processing, real-time data transformation, real-time data analytics. So I can give a couple of few examples. So let's say that's if we want to do stock trading and we really want to know, okay, what happened over the last probably 5 minutes, or probably continuously monitoring, okay, what's happened over the last 5 minutes, or probably last 10 minutes, right? And in this case, well, it's not convenient to use the OLAP database or data warehouses to do such kind of things because, those systems are basically batch-based systems, and they are better optimized. They are highly optimized for processing large-scale data, right? For probably a day's data, right? For yesterday's data. But if you want to use such a database to process, okay, continuously processing what happened over the last 5 minutes or even last 10 seconds, they are actually not a very good fit. So that's where essentially RisingWave can be a pretty good fit.
In this case, yeah, okay. In this case, I think people would normally, when we look at Postgres, for example, they would probably go for a materialized view. But the problem is that a materialized view is an all or nothing refresh, which means you have to recalculate everything. And I think that is one of the big differences to RisingWave, where you really just feed in data and you get this like live updating of the actual data table, basically.
Yeah, whenever people talk about the materialized views in Postgres, specifically in Postgres, okay, and people were, so I saw in Reddit a few days ago that's what people say that when you need to have Postgres materialized views, people say that a common say that okay, if you want to have speedy results instead of timely results, you should use materialized views. Because in Postgres, whenever you create a materials view, you get the results, and the results will not be directly updated, will not be automatically updated. So you actually have to input a command called refresh materials view, right? So that's where the Postgres will recompute the materials view for you, and you can essentially store the easiest way to think about the Postgres materials view is that you can just store the results, store the computation results in a table. It's static. It's not that dynamic. If you change the base table, if you insert new tuples into the base table, the materials view won't change. And that's Postgres materials view. But in our case, we're in RisingWave's materials views, and it's different. Well, it's like, okay, every time the new data comes in, right? Well, coming from Kafka, or you just insert a tuple into your Postgres or into whatever your upstream system is, we actually capture the changes and refresh the materials views for you, so that you can always see the fresh results, fresh and consistent results. Right? Yeah, that's what you do.
The way I love to talk about Postgres materialized views in the past is like you have your own personal secretary, and she's shredding the report from last day like all together before she starts in the morning to do it afresh. That's about what it is. You're basically just throwing everything away and you start up from the bottom. As you know, I've been with Timescale before, and that was exactly one of the reasons why we also said, okay, we need to have a better solution with time series, with terabytes of data. You cannot do this. And personally, I think, and we talked about that, RisingWave would have still been a step up from the continuous aggregates, and I actually played around with that, and it gave a great experience. we talk a lot about stream processing, and you kind of hinted at that. Maybe give me or the audience 1 minute explanation into specifically stream processing. Like what do you expect from that?
Yeah, actually, a lot of people are not quite familiar with stream processing, right? Well, but if you consider, let's say, Snowflake or Redshift, so this kind of systems are like batch system, right? You probably just upload the data from S3 into, let's say, into Redshift, and then you run a query and to generate a report, right? So basically, for such a query, it's run on top of your batch data. You have probably your last day's data, or probably last 7 days data, or probably last year's data. That's batch data, right? And then you run a query on top of this data and then generate a report. Okay, what happened over the last 7 days? What happened over the last 1 year, right? That's batch processing. But stream processing is totally different. It focuses on fresh data and fresh results, which means that it will continuously ingest the data from upstream services. And then every time a new tuple, a new data comes in, a new event comes in, it will trigger the computation and refresh the material. It refresh the results, refresh your computation results, so that you can always see the latest results. You can gain the insights from your streams, right? Or data streams. So people may ask, okay, when I need to have when I need to do stream processing. Think about it. I just mentioned probably stock trading, right? Or if you want to do something like IoT monitoring, right? Where you have a energy plant, probably you really want to monitor what happens right over the stuff. Yeah, continuously monitoring the voltage, right, for all these kinds of metrics, right? So you definitely want to do stream processing. Or if you want to, let's say, if you are a payment service, or probably you are building a billing service, you really want to detect the frauds of the in real time, right? So you should not say, okay, I will do the billing every single month, and then I found that okay, there are a lot of frauds there, so it won't work. You should just detect a fraud in real time so as to avoid any kind of loss, right? Yeah. So that's stream processing.
Right, and I think there's not too many actual real-time processing engines. A lot of these engines that look real-time and real-time not in the hardware real-time way, but like software real-time, they still do batching. They call it micro batches, which is like a couple of milliseconds. But it's still not real time, right? That's the main difference, and it's one of the differences to something like Hazelcast Jet, which also does micro batches, but looks basically real time because the batches are so small.
Yeah, well, I think we're definitely a couple of systems that's doing micro batch, and I think one of the most famous ones is Spark streaming. Right, well, because Spark is like everyone knows that. It's definitely a batch engine, and but definitely people have the demand to do continuous computation, and they say that probably I don't really want to rewrite my engine, right? Why not just reuse Spark, right? What do we have? Reuse what we have, right? Then that's why they have the Spark streaming, basically chop up your data streams into multiple buckets, so probably multiple. I don't know what it's called for. Micro batches, right? So chop up the streams into micro batches and do computations in every single batch, and then put the results together, and that's what they do. And so it's great. Right? It's definitely great technology, and especially for Spark, right? So if you come from Spark, and it's kind of like quite straightforward. But if you really want to do something like a true real-time event-driven architecture, right? If you receive events from your upstream services, like if you receive events from your, let's say, GitHub events, right? Or probably receive the events from, let's say, Twitter events, right? You probably really want to do something like monitoring, right? Then you probably micro batch way may not work, and then you probably need to do something like a true stream processing. Yeah.
So You're talking if you said before if you ingest data into RisingWave, how would I do this?
Okay, so in our case, well, I mean, we definitely support a lot of ways to ingest the data. The easiest way is that, okay, look, I probably didn't really mention this before, but well, RisingWave is Postgres compatible. It's not based on Postgres, but so I actually spent a lot of time working Postgres in the past, well, especially during my PhD. But RisingWave is not based on Postgres, but it's Postgres while compatible, and all the behaviors are exactly the same as Postgres, or similar. I cannot say exactly the same, and also very similar to Postgres. And you can just run Postgres queries in the same SQL queries in the same way as you use Postgres. So in terms of the ingestion, definitely you can just create a table, insert tuples into it, right? So that's the easiest way. But let's say that if you have something like Kafka, a Kafka service, an event streaming service, then the only thing you need to do to ingest the data from your Kafka is to create, in our case, where it's like create a source from Kafka. And so that's what RisingWave will directly continuously ingest the data from Kafka. Or let's say that's okay. If you want to have, let's say you don't really have Kafka, you just have a Postgres or MongoDB, MySQL, whatever, right? Well, Oracle, even Oracle SQL Server. So you have those kind of services, and then you want to ingest the data, right? Because for that, there's data changes, right, from the upstream services. You want to capture these changes. The only way you need to do in RisingWave is to create a source, and from, let's say, Postgres, from MongoDB, whatever, right? And definitely, so RisingWave is a streaming service, stream processing system, but we support ingesting data from batch sources, like say S3 or Iceberg. So why we need to do that? Why we do that? Because essentially we find that many people want to, join the streaming data with a batch data. Let's say that's where if I have a clickstream, and also have, let's say, user info, right? Well, from user info table from let's say from S3, starting S3, right? I really want to join the events, yes, in the click streams with the table in order to enrich the stream before dumping the result, delivering the result into my data warehouse or probably a data lake, right? So that's what we do. So we support ingesting. Definitely, you can, to summarize, you can definitely use inserting two statements, or you can use a statement called create a source to ingest the data from your, no matter whether it's Kafka, whether it's Postgres, or probably S3.
I think the easiest way, and you mentioned that, is basically creating a source and using Kafka and Debezium to capture the change events from the database and just drop them in right away.
That's right. Essentially, we use Debezium internally. Yeah. So you do not need to have, let's say, Kafka plus Debezium. Let's say that's where if you have a Postgres, you can just use RisingWave, and we have basically run Debezium for you.
Okay. So RisingWave is implemented in Java?
No, it's in Rust. So so some fun fact. Well, I'm a founder of the RisingWave, but I do not really know Rust. Well, I do not really code in Rust. I actually am a C++ programmer. So I started in 2021, and I wrote the first probably 10 or 20,000 lines of code. Probably a first 100K thousand lines of code in C++. But all employees told me that, okay, look, C++ is outdated which I don't really agree with, okay? And but we do find that there are a huge problem with C++ in a small team. So the problem here is that, if you want to do debugging, it's super painful. Because in C++, we know that, I came from, I started working on C++ for probably 10 or probably 15 years ago. And since then, it keeps evolving, right? We have C++, you have C, then C++, C++11. Nowadays, probably, I don't know, probably 20 or 20 something, right? 23, right? Yeah, it's kind of crazy. And it's always evolving. And it's really hard to for people to unify their styles, right? For some people probably use malloc, and and some people malloc and free, and some people use for new and delete, and some people use for unique pointers and spot pointers. And I know that's probably there's some more advanced semantics nowadays. So it's kind of very very complicated. If you run into some bugs, CG11, segment fault, then you will have to probably spend a few days to debug. So one was in Redshift. Redshift was coding C. Redshift was based on Postgres, and that was C code. And then since then, we added C++ code and different version of C++ code. And I still remember that, right? Essentially, for one single bug, it's about UDF in Redshift. I spent one person spent 2 weeks just of debugging for this bug. So that was terrible experience. I never really want to do it again. So yeah, and we hit into the same problem, still very similar problem in building RisingWave in C++. So, and I talked to many people about this, in big companies, and they told me that, you probably should trust your employees and probably try to, probably. I definitely trust them, okay?
I think that is a very, very good advice for many people. Trust your employees. You hire them for a reason.
No, I really trust them, right? But the thing here, that's why I don't really want to be the only one that uses Rust, right? But definitely, I think Rust ecosystem is great, right? So many systems. I have to say there are probably also thanks to crypto, right? Well, crypto, I know that a lot of crypto companies actually use Rust. And then I heard the news, Microsoft try to introduce Rust into their environment, right? And then Facebook, Meta, right? And then also even Amazon, they also said, okay, we probably will try Rust. So then I decided to basically to delete all the entire code base and write it in Rust. So there was a pretty famous blog. I don't know, probably got probably 1 million views of that blog. And that blog was talking about, how we migrated from the C++ to Rust. Yeah. So
I think I know that blog post.
Pretty fun experience, yeah.
But Debezium is implemented in Java. That's why I thought.
Yeah, it is in Java. It is in Java.
So there is like a little bit of Java code to do the integration with Debezium.
Yeah. All right, definitely. We do not really talk shit about the Java, right? You know.
No. Well, no, it's fine, but.
No, I personally, I know that's what people always say, that's where Java is slow and things like that. But to be honest, so I agree that Rust is, more modern language, right? Forget about the performance, forget about anything, right? It's more than a language. But I have to say there's a lot of, if you want to have a better experience or integration with your, the big data ecosystem, probably you still have to write some Java code. I have to say that, so if you check out if you want to have an integration with, let's say, Kafka, integration with, for sure, Debezium, right? Integration with some other systems, probably Spark, right? And so you actually have to have Java code. It's not inevitable, but we do see that's what probably there are some performance issues. For example, we actually support sending the results from RisingWave to Iceberg format. So Iceberg was in Java. So we found that syncing data from RisingWave to Iceberg was super slow. So that's why we collaborate with some other companies and created a project called Iceberg Rust, Iceberg RS. So you can check out it's an Apache project under Apache Foundation, and it's basically Rust version of Iceberg.
I love in Java everything has J something. In Rust everything has RS -RS.
Yeah, that's right. Yeah, there's another project called Delta RS. Right, where it's basically a Delta Lake, the Rust version of Delta Lake. It's pretty. I was actually talking to another guy. and he was working on the Delta RS project. It's definitely I know that's why people are moving to Rust, but we have to admit that's why a lot of projects were still in Java, and we have to be open-minded, and we have to be have an integration with all these kind of systems, right? We should not say that okay, move everything into Rust. I don't really think that will happen within the next 5 years.
Right.
But anyways, yeah.
All right, yeah. Let's keep going with the topic because
sure, yeah.
we kind of drifted off. We're cloud podcasts, so tell me about RisingWave Cloud.
So RisingWave Cloud is probably easiest way to run RisingWave. But I'm as a founder. I mean, if you talk to our salespeople, they will always say that's okay. Just sign up for cloud platform, and then you can get it for free, right? For the probably I don't know, forever free or whatever, right? But my suggestion is always like, okay, you actually can try it out in your local machine, right? For your local laptop, right? Probably you have a Mac and try it out, right? There, don't just sign up, right?
So that's the difference between salespeople and engineers. I'm the same.
So I always test out all kinds of stuff in my own laptop, right? Well, that's easiest way for me, at least. Well, probably my sales guys will probably hate me, but I have to say that that's the easiest way. But anyways, regarding RisingWave, I have to say that RisingWave Cloud is also the pretty easy way. Still officially is still the easiest way to run RisingWave. And we run everything in Kubernetes and in AWS, GCP, and Azure. So let's talk about AWS. Then it's always in Kubernetes, and we use S3 as the as the storage for persisting all the data there, and run the computation in EC2. So, and we also use EBS for caching purposes.
Do you use the hosted Kubernetes services like EKS, EKS?
Yeah,
all right.
Yeah, we do use EKS, yes.
All right. I still see a lot of people that say, we use Kubernetes, but we use EC2 machines and we set up our own clusters.
For us, it's more like a liability issue. We don't really want to manage too many things. But I do see that many companies, especially enterprise companies, where they run their own, everything on their own. So we do support for Kubernetes operator, and also Helm. So that's where they can just deploy in their own environment. Yeah,
it is like you've read my next question. Like, okay, so there is a Kubernetes operator. That means if I want to go into production after I tried it on my own machine, or I used RisingWave Cloud, and I feel like I don't want to use a RisingWave Cloud. I want to have it running my own in my own environment, which there is good reasons, right? Compliance, security, all that kind of stuff. So I would use, you said Helm chart or the operator, but I think the operator is the better version and probably takes a lot of like the actual operational overhead away from you, right?
Yeah, sure. But what I have to say is, it totally depends on personal their environment. So yeah. But I do see that's why a lot of people are using operators. Yes.
Okay, so it sounds like you're not much of a fan of operators.
Well, I'm a fan of Kubernetes for sure, and so definitely I'm also a fan of operators for sure. Yeah.
Okay, fair enough. From my perspective, Helm charts are great for everything you just install, but you don't really have to do operation on. For example, Postgres. I would never recommend anyone deploying Postgres in Kubernetes without using an operator, because it's not just the database. There's like so much stuff that needs to be done around it.
Yeah, so actually I do not really recommend self-hosting Postgres because there are so many options, right, for RDS. Yeah,
we agreed to disagree. Very good. Very good. We agree to disagree. All right. For the sake of time, because we crossed the 25 minutes about 2 minutes ago, what do you think is like the next big thing? What do you see on the horizon? Could be anything.
Yeah. So I have to say that's what it's I bet on three things: Postgres, Kafka, and Iceberg. So I do not really put my bet. Well, I have to say I do not really put my bets on certain technology. I have to say that I do not really put my bet on, let's say, Confluent. I do not really do that, but I do really put my bet on the standard, open standard, Postgres, Kafka, and Iceberg. So the thing here that's what is Postgres? Postgres is essentially the operational database that hosts the a person's teams or companies' operational data. Well, Kafka hosts companies the streaming data. Well, Iceberg is should be a place, and will be the place to host the historical data. So that's why I believe that if you want to build a new system, in 2025 or even 2025 next year, then you should definitely, or even if you want to start from now, right? Well, you should definitely bet on these three open standard. I'm not talking about technology because I know that there are definitely all kinds of versions of Kafka, all kinds of versions of Postgres. But I have to say that you have to bet on the open standard. And I also bet on the better integration and better ecosystem. And I do believe that Postgres, Kafka, and Iceberg, a cheaper version and a more cost-efficient version of this kind of standard would be the big thing for the next big thing. But yeah, people probably also talk about the AI, but AI is it's probably it's a great technology, and it's a big thing.
All right, fair enough. I was just about to say it's so uncommon that people do not put AI front and center. That it is very refreshing every time it happens. But
if it's an AI podcast, why they don't put an AI in a center?
Yeah, that is true. I would basically say if you start building a new technology or a new product next year, we hopefully figured out that not everything needs an AI agent. So let's see.
Sure,
all right.
Yeah.
Last question. Is there anything else you want the audience to know?
Okay, so don't just focus on AI. So think about the data infra. So because I talked to a lot of people, and people say that why you are still working on data infra, right? Data infra is that, right? Things like that. So look at the Snowflake stock, and it's dropping. It's just dropping every single day. So don't think about that. So Snowflake is still it's their business, right? So it's nothing to do with our business, right? It's nothing to do with some other people's some other company's business. But I do believe there's a future of data infra is still evolving. So look, I do believe it's the modern data infra. If you look at Snowflake, Databricks, or probably Redshift or whatever, right? These kind of things, these kind of systems are actually built for enterprises. But I do believe that the developers or SMBs are underserved, and they should deserve better data infra, right? So if you're talking about, let's say that I want to run a startup today, or probably tomorrow, or probably next year, should I just start with Snowflake? No. Snowflake is too expensive, right? I should not start with that, right? I probably should start with Postgres, or probably start with some simpler things, right? But Postgres, right? I know that's where there are a bunch of Postgres startups, right? Well, Timescale, nowadays where they essentially sell Postgres, Neon, Superbase, all these kind of vendors. So they're great. But it's more than just Postgres. We have to reinvent everything. Reinvent Kafka, reinvent data warehouse, reinvent data lake, reinvent everything in this data stack. So I do believe that's true. There are a lot of things to be done in the data infra space. So
all right, fair enough. You're certainly an engineer and not a salesperson. That question normally goes to you want to sign up for the cloud, you want to try it out if you have a use case. I tried RisingWave. I told him before the actual recording. I loved it. Really try it out. It's really cool technology, and it has a lot of use cases.
Yeah. If you don't really want to talk to ourselves, talk to me, right? So I can talk about the technology, talk about how to use RisingWave, and whether your use case is the best fit, right? Some people told me that probably they want to store time series data, so store some operational database, have some operational data, and do something like random stuff. Well, I will always give my unbiased opinion. I will not tell you that, okay, you can use RisingWave to do everything, right? So that's,
I like that because
what I want to say.
Yeah, I like that because I'm very much the same. So by the way, there is a great Slack team. Join that if you have any questions about RisingWave. And I think you're in the Slack as well, so you're always up for answering
sure.
questions.
Yeah, just DM me, and I will just I will just definitely get back to you. Yeah.
Perfect. So, thank you very much for being here. We're way above time, but it doesn't matter. It is what it is. That's how conversational podcasts work. Thank you for being here. Thank you for being an amazing guest.
All right.
And for the audience, you know the spiel. Same place, same time next week. Let's see who will be up next.